Can robots feed the world? The answer may surprise you. By 2024, it's predicted that a staggering 70% of farms will incorporate robots into their operations. The market for agricultural robots is exploding. Experts predict it will grow from $13.4 billion in 2023 to a staggering $86.5 billion by 2033. That's a 20.5% annual increase. Facing labor shortages, climate change, and rising food demands, farmers are turning to robots, as traditional farming methods struggle to keep pace with the demands of a growing global population. The future of farming is here, and it's automated. Let's delve into the reasons behind the use of robots on farms, explore their various applications, and understand what they truly are. Modern farming faces a multitude of challenges, including labor, sustainability, and climate change. Labor. One of the most pressing issues is the growing shortage of agricultural labor. As younger generations are less inclined to pursue careers in agriculture, farmers are finding it increasingly difficult to find skilled workers. According to recent statistics, 55% of farmers report being affected by labor shortages, with 70% of California farmers unable to find enough seasonal workers to meet their needs. Adding to the challenge, many farm workers are undocumented, making the labor situation even more precarious. The reliance on manual labor for tasks like planting and harvesting has become increasingly untenable, prompting a search for automated solutions. This labor shortage is driving up costs and putting a strain on production. Sustainability. Another major challenge is the need for greater efficiency and better resource utilization. With the global population expected to reach 9.7 billion by 2050, farmers need to produce more food than ever before, and they need to do it sustainably. Farmers are under pressure to minimize their ecological footprint while maximizing output. Traditional farming methods are often resource-intensive and can have a significant impact on the environment. As a result, environmental sustainability is increasingly becoming a concern. Climate change. Climate change is also posing a significant threat to agriculture. Extreme weather events such as droughts and floods are becoming more frequent and severe, damaging crops and disrupting farming operations. Hurricanes Helene and Milton, for example, left behind a trail of devastated farming communities that will need a long time to recover. Farmers need to adapt to these changing conditions and find ways to mitigate the risks posed by climate change. These challenges are complex and multifaceted, and they require innovative solutions. Robots offer a potential solution to many of these problems, providing farmers with the tools they need to increase efficiency, reduce their environmental impact, and adapt to the changing climate. Applications of robots in agriculture. Planting and weeding, harvesting and monitoring. One of the most common applications of robots in agriculture is in planting and weeding. Planting robots can sow seeds with incredible accuracy, ensuring that each seed is placed at the optimal depth and spacing for optimal growth. These robots use advanced sensors and GPS technology to navigate fields and plant seeds with sub-centimeter accuracy. Digital Farmhand, for example, an automatic robot developed by the University of Sydney's Australian Centre for Field Robotics, can detect and identify plants from weeds, and carry out a range of tasks including planting, removing weeds, analyzing the soil, optimizing resource use, mapping fields, and collecting data on crop health and yield. Carbon Robotics' laser weeder uses AI and computer vision to differentiate between crops and weeds, employing lasers to destroy weeds while preserving the surrounding plants. Likewise, Nexus Robotics' R2 Weed 2 autonomously strips weeds from fields while gathering data for soil analysis and environmental monitoring. This precision planting leads to several benefits, including improved crop yields, reduced seed waste, and reduced labor costs. By ensuring that each seed is planted at the optimal depth and spacing, farmers can maximize germination rates and ensure that each plant has the best possible chance of survival. Precision planting eliminates the need for overlapping rows, which reduces the number of seeds required, saving farmers money and reducing waste. Planting robots can work autonomously, freeing up farmers and farm workers to focus on other tasks. Harvesting. Harvesting is another area where robots are making significant inroads. Harvesting robots can work tirelessly for hours on end, picking fruits and vegetables with speed and precision that surpasses human capabilities. They use a combination of cameras, sensors, and artificial intelligence to identify ripe produce and carefully pluck it from the plant. This is particularly beneficial for crops that are delicate or difficult to harvest, such as strawberries or lettuce. Two of the most popular harvesting robots are Harvest Crew and Agrobot E-Series. Harvest Crew specializes in strawberry harvesting and uses a vision system to identify ripe berries. It can pick a plant in about 8 seconds, significantly faster than human laborers, and operates with a 98% accuracy rate while requiring only one supervisor. Agrobot E-Series robots are equipped with multiple arms and can autonomously grips, cuts, and packs produce, ensuring that only ripe fruits are selected for harvest. The benefits of using harvesting robots include reduced labor costs, increased efficiency, and improved product quality. By picking only ripe produce, these robots help to ensure that only the highest quality products reach consumers. Monitoring. In addition to planting, weeding, and harvesting, robots are also being used to monitor crops and collect valuable data about growing conditions. Drones play a crucial role in crop monitoring by providing aerial imagery and data analysis. They are equipped with a variety of cameras and sensors that measure factors such as soil moisture, temperature, humidity, and nutrient levels. This data is then relayed back to farmers in real time, providing them with valuable insights into the health of their crops. Farmers can use this information to make informed decisions about irrigation, fertilization, and pest control. Among the most popular monitoring drones are Precision Hawk drones and Agrim-X. Precision Hawk is a leader in agricultural mapping and analytics, empowering farmers to pinpoint growth trends, evaluate plant health, and streamline farm operations through the collection of real-time data. Their drones come equipped with a versatile swappable payload bay, allowing for the integration of various camera sensors. Available options include visual, thermal infrared, multispectral, LiDAR, and hyperspectral sensors, catering to a wide range of agricultural needs. Despite the manufacturer filing for voluntary Chapter 7 bankruptcy in December 2023, their drones continue to be widely utilized on farms globally, demonstrating their lasting impact on the industry. Agrim-X is an autonomous drone created by Suwind, an Indian company, for precision agriculture. It utilizes advanced computer vision and AI algorithms to deliver high-resolution images of crops, enabling farmers to make informed decisions. With its autonomous operation, Agrim-X navigates and collects data independently, while its lightweight design allows for easy maneuverability through fields, capturing data from various angles. The benefits of using monitoring robots include early detection of problems, optimized resource use, and improved crop yields. By providing farmers with a better understanding of their crops and growing conditions, monitoring robots can help to improve yields and increase profitability. Next, let's take a closer look at a real-life example of a farm that has successfully integrated agricultural robots. Case study, Bowles Farming Company. A noteworthy example of robotic technology in agriculture is the Bowles Farming Company, situated in California's Central Valley. This sixth-generation family-owned farm has made significant improvements to its operations by adopting advanced agricultural robotics, which has enhanced both productivity and efficiency. It operates on 11,000 acres of land and grows various crops, including fresh market and processing tomatoes, cotton, corn, melons, and alfalfa. Two of the most prominent robotics implementations at the company involve drones and handheld applications. Initially purchased for aerial photography, drones are used to quickly survey and monitor large areas, capturing data on temperature, soil moisture, and irrigation efficiency. This immediate feedback data enables swift adjustments to farming practices, such as applying fertilizers or adjusting irrigation schedules based on current crop needs. Handheld tablet applications are used to streamline farm management by tracking all activities associated with weather metrics. This digital approach enhances operational efficiency by centralizing and correlating data with weather conditions and other relevant metrics to improve planning and resource allocation. Finally, handheld applications foster better communication among team members regarding daily operations and crop management strategies. These represent just a few examples of the innovative robotic technologies making their way into farming operations. The full range is extensive and continually expanding. The adoption of robotic technologies has significantly improved productivity and cost efficiency. This was achieved through better crop management, increased labor efficiency, and substantial cost savings. For example, drones replaced manual labor for monitoring large fields and optimized water use for irrigation and fertilizer application by adjusting rates to suit specific areas of the farm. Bowles Farming Company's long-standing history in California agriculture, a region known for its progressive farming practices, suggests it is at the forefront of adopting robotic solutions. Their example serves as a model for other farms looking to harness the power of robotics to navigate the evolving landscape of modern agriculture. The future of farming is inextricably linked with technology. The possibilities for robotic farming are vast and inspiring. They include autonomous robots, specialized robots, and advanced AI systems. First, autonomous robots. Imagine swarms of autonomous robots working together in coordinated efforts, tending to vast fields with unparalleled precision and efficiency. These robots could communicate with each other, sharing information, and adjusting their tasks in real time to optimize crop production. Second, specialized robots. As robotic technology advances, we can expect to see the development of highly specialized robots designed for specific tasks. These could include robots for pruning, weeding, thinning, and even for applying pesticides with pinpoint accuracy, reducing chemical use and minimizing environmental impact. Last, advanced AI systems. Artificial intelligence will play an increasingly important role in robotic farming. AI-powered systems will analyze vast amounts of data from robots and other sources, providing farmers with unprecedented insights into their crops, soil, and weather patterns. This data will enable farmers to make more informed decisions, optimizing every aspect of their operations. In summary, integrating robots into agriculture is still in its early stages, but the potential is undeniable. By embracing these technological advancements, we can create a future where farming is more efficient, sustainable, and resilient, ensuring we can feed the world's growing population while protecting our planet for generations. What are your thoughts on the role of robots in the future of farming? Share your insights and join the conversation about this transformative technology. Thank you for spending time with us today. We will see you in the next video.